Today we are learning about linear differential equations. So coming to its definition, a differential equation is said to be linear if the dependent variable and its derivative occurs at the first degree only and they are not multiplied together. Here what it states that there is a simple linear equation where its highest degree is 1 and its dependent variable and its derivative are not multiplied here. For example, in the standard form dy by dx plus py is equals to q, y is the dependent variable and x is independent. So dependent variable derivative, which is dy by dx, it's not multiplied together. It's dy by dx plus py is equals to q. Here p and q are the functions of x. So when we have this equation, now it's time to find its solution. So for finding its solution, we need an integrating factor where we can multiply to the formula and we can get the solution. So first we have to find integrating factor. Integrating factor is equals to e to the power of integration of p into dx. So we have to integrate the p value which is there in the standard equation. We have to integrate it with respect to x. Then there is a formula for solution which is y into integrating factor is equals to integration of q into integrating factor dx plus c. Since it is the solution, we can see the examples for this. Coming to the first example, solve dy by dx plus y is equals to q. Here it is in the form of dy by dx plus py is equals to q, where p is equals to 1 and q is equals to x. So integrating factor will be equals to e to the power of p dx, e to the power of integration of 1 into dx, which is e to the power of x. So we have to substitute in the formula of the solutions, which is y into integrating factor is equals to integration of q into integrating factor dx plus c. So we will get y into e to the power of x is equals to q into e to the power of x dx plus c, where q is equals to x. So you can solve this by Bernoulli's theorem or else you can solve this by UV formula. Both the methods can be possible. You can use Bernoulli's theorem or else by parts rule, means UV formula. Here Bernoulli's theorem, what it states that integration of UV dx is equals to first term as it is. Okay, here u and v are being taken in the order of Euler rule. Here u and v can be decided by Euler rule, where I stands for inverse trigonometry, L stands for logarithmic functions, A stands for algorithmic functions, T stands for trigonometric functions, and E starts from exponential functions. So we have to give the prior for left side to right side. So here I used Bernoulli's theorem or else you can use by parts rule also. Bernoulli's theorem states that you have to keep it as it is, and integration of second function minus differentiation of first function and double integration of second function. It continues till one term gets vanished. Since I have used a Bernoulli's theorem, x e to the power of x, I have got the answer. This here x is algebraic functions, e to the power of x is exponential function, so x will be act as u and e to the power of x will be v. So I have applied Bernoulli's theorem and I have got the answer y e to the power of x is equals to e to the power of x minus 1 plus c by e to the power of x. Let us see another example. Solve dy by dx plus y by x is equals to x. Here it is in the form of dy by dx plus py is equals to q, where p is equals to 1 by x and q is equals to x. integrating factor will be e to the power of 1 by x. So integration of 1 by x is log x. So e to the power of log into any function is, the answer is that function. So we are taking e to the power of log x as only x. So the solution is, means the solution of integrating factor is x. So we have to substitute in the formula y into integrating factor is equals to integration of q into integrating factor dx plus c. We will get x into dx plus c. It will become x square. So after integration it will become xy is equals to x cube by 3 plus c. Thank you.